Yes.
Look what I bought with my own money at Hot Topic. This.
It's a bracelet?
Uh-huh.
Dude, I'd be afraid I'd stab everything with
I
that.
have stabbed myself.
Yeah, I was gonna say, I'm pretty sure I would incessantly stab myself with something like that. So it's pretty cool.
One of the spikes came off.
Oh my gracious.
I woke up one morning and I was like, wait, where's the spike going?
Right.
What did you do?
What's going on?
Blame the cat.
Blame the cat. That always works. Blame the cat. It very well may have been, right? They're always guilty. Hey, Senya.
Hi.
Good morning, sweetie. All right, let's see. Good for battery. Yeah, there are two of me. One of them's my iPad and one of them's my computer.
Why do you have to have two of you?
Because she can see. Want to turn that on?
How can everyone open the door except me?
I don't know.
I
know what
don't
with that
know.
door.
The door dislikes me.
Mm-hmm. It does.
I don't even know where
Good morning. You have some stuff over there by your chair.
Me?
Yes. That you can go and throw out, but we can see your class can sit in here today. I'm gonna have to put the older kids in here, I think. But you guys can sit in here.
Where is it?
Can you see it? Hey, Sky.
Oh, it's the earrings.
Oh, those are cute. Did you make those? Very cool. All right. How's your new nephew? Is he cute, cute, cute? Yeah. Y'all know that Sky has a new nephew? Yes. Sky, tell everybody your awesome news about your new nephew.
He was born last month.
Mm-hmm.
He's right now.
He's where?
His name's Wyatt.
Don't you have pictures to share? What kind of an are you? Oh my goodness. No, he's super cute. I've seen pictures. He's very sweet. No, I mean, let's just banana real fast. You can't have it.
Why can't I have the banana?
Because he already has stuff. No, I know you're doing a trick. But hold on. I'll get you your bully stick. You wait. Just wait. I promise. Mm-hmm.
And he's like, I don't want it.
No, I want that. I want that. This is mine. But I'll get you your breakfast. Hold on.
What are you gonna do for it? He's like,
Oh, he's got to work.
he's like, no, I want a banana.
He's got to work. Sure. Good. Whoa. It's fun. Wait. Bang.
Wait, what?
That all the way down. Head down. Try that again. Come here. Jocelyn wants to use it. Bang. Good boy.
Oh my gosh, you
Yes,
taught
I
him.
did.
You taught him that?
I think Drew taught him that one, yeah.
It says game.
All right, I don't know who that is, but admit. All right, let me come over here with you guys. Y'all are, I think, cool for me to sit over here this morning. Let me bring this stuff. Wake up, cat. Now I'm going to fight with it. That's fine.
Revenge.
Give me a second to fight with it, y'all, and then we'll be good. Switch that. I still have a screen. Okay, good. There we go. Check my speaker. Gonna be like that, huh? Fine. Fight with me, gosh, come on. This thing's crazy. There it goes. All right.
It's like, do you want to decline this? What you've been trying to do?
Yeah, do you want to do what you did? Why is there volume on this? I bet I turned it off, I thought.
Why is there an echo?
It's on here. I'm turning it all the way down. Where it was supposed to be. Wow, now it's fun. That was fun.
It was not.
Not so much, huh?
It was not fun. Not fun.
Let me switch this one off. Go back the other way. If I come in this way and do. So did everybody have a good Christmas and a good New Year?
Yeah.
Awesome. All right. We should be, let me see, switch. All right.
Danny,
Yes, ma'am.
in 2 days I'll be turning 11.
Ah, wow. 11. That's pretty awesome.
Wait, now I need to do math.
Are you going to do math?
I got for my birthday.
Oh, yeah? When's your birthday, Eleanor?
March 30th, 2010.
March 30th. Okay, all right.
Yeah, I'm not doing that.
Yeah.
Yeah.
even need the year.
Huh?
We didn't even need the year to calculate that.
Yeah, because she'll be. All right, let's go. Hang on. Where am I going? All right, gang. Well, welcome back. So Drew and Cole are out of town, believe it or not. We decided to brave them going on a trip that they had planned for a they had planned to go skiing. So
Our family goes skiing every year, but we You keep on working out.
We usually go to the Ozarks with the my mom's friends each year. It was gonna be the tradition started last year, but now we can't do it.
Yeah, we just, I can drive out of state yet.
Tradition really
Start at like 4 or 5. We just go.
well, Jason and the boys went last year to Colorado and they had a really good time and they wanted to go back. And Jason had a bunch of passes. So it was either let all that free money go or go for it. And they decided that the only really risky part was the actual plane. And a lot of people have been traveling on planes and that's been pretty safe as long as you stay masked up. Well, the ski lifts are social distanced. You can only get on with your family and you have gloves and everything. So they decided to go for it.
You have to wear masks while skiing?
Yes, in Colorado, you have to wear masks if you're in public, period, even if you're outside. So everybody's masked everywhere. And the restaurants are not open except for carry out or delivery. And so they're in like an Airbnb that has a mini kitchen. So this is why technology is awesome. And this is why this pandemic could be so much worse because we have all this technology now. But I went online to the local market and ordered all of their groceries so that there were meals they could piece together. Because when we travel and we stay in Airbnbs, like usually I go out or my mom and I go out and we buy whatever we need. It's going to do that a couple times, I think. But we buy whatever we need and then we have it so that we know that these 10 things will make 4 meals. You know, the guys don't do that. So I did that for them, which I thought was pretty cool.
Do you know if Ivy or Jewel is coming?
If who?
Ivy or
Jules
Jewel?
Jules is not coming today. So does she. Jules got COVID. Yep, and so did her mom. Come here, baby. They're on the mend. They're okay right now. Here, you coming? So they have to stay gone for a while. But yeah. So say a little prayer for Jules' family that they get better. I know we're gonna miss her today.
We're on.
I know. I see you guys. I see you guys there. They're in the, whoops, they're right here in the group, right here. That's them. All right. So we got a couple people out today. Obviously, those girls are out, and then my boys are out, and a couple of other people. So it's gonna be a light day. That's cool. So you guys saw, if you were able to get your notes, which you should have been able to get your notes, that today's lesson wasn't even in the book. What we're doing is we're trying to keep in line with what the upper class is learning, and they're spending more time on these topics, but with a lot of detail. It gets very granular, lots of detail. So what we're going to do is we're going to take the same concepts, but hit them way more high level. So there is Jocelyn. So with that said, we already talked a little bit about enthalpy before break. So now this is enthalpy, intermolecular forces, states of matter. You guys know about states of matter. So really the next 2 weeks or so, what we're talking about is the energy differences between different states of matter, and then the energy needed to change from one state to another, which we talked about. If you're going to go from a solid to a liquid, you're increasing energy, and then from a liquid to a gas, you're increasing your energy. So it's going to be kind of, actually guys, kind of easy the next couple weeks. So enthalpy. Can anybody kind of describe enthalpy in their own words? What's a good word for it? Heat. Heat's a good way. Yeah, it measures heat. What specifically? What about the heat? Yeah, added or removed. Perfect, Alec. Yeah, it's about change in heat. So you want to think about, do you remember the symbol for change? Do you remember what that symbol looks like? It's a Greek letter. It's a delta. It looks like a triangle. And think about a Delta jet and their logo that's on the tail of the airplane.
Yeah.
What shape is that? The triangle? Yeah. Lily, you look tired. Are you tired today? Did you sleep in all break? You did, didn't you? Yeah. I'm with you. I did too. Now it's like,
I wake up at 6 a.m.
That's funny.
I go to 7 at 8. I go to bed at 3.
Oh no, I can't do that. So yeah, we're thinking about a delta heat, the change in heat. So your enthalpy is the sum of all the internal energy and the product of pressure and volume. Okay, so here's where pressure, and bless you, here's where pressure and volume are going to come into play, which we didn't really talk about before when we talked about energy and states of matter and changes. So if you add pressure to a system, which we'll see, it can affect the state of matter. So I want you to think about what powers your grill outside. If you don't have a charcoal grill, what do you have? Propane. Yeah. And so that's a lot of propane, right? Like if you were to put a balloon on your propane tank, or for example, when we have our little tiny propane tank out that we use for our Bunsen burner, it's like this big, right? Yeah, but it lets gas out for a long time. So how do they get all of that gas inside the little container? What do they have to do? They pump it in, right? Why is the container made of thick metal and not something else? Yeah. They put all that gas under a lot of pressure. And what happens to it when they put it under pressure like that? They pump it in, pump it in, pump it in, pump it in. It tries to expand, but it can't. So what actually happens is all those particles, think about particles in
Miss Danny.
Yes.
Can everybody else?
It does. So I think I'm gonna mute this one because that's annoying. It's really echoey over here. Hang on, let me. I think I should be able to hear.
Oh, that's so much
the online
better.
people on
You
my screen.
did.
Hopefully, so yeah. So it will, if you pump air or anything, propane, oxygen. You ever seen liquid oxygen tanks? Like the ones they carry around in hospitals, or sometimes people have them at home. Right, and the oxygen will, think about the particles in a gas, right? What are they doing? They're bumping around. They're bumping into each other, but they're not very close, right? They're pretty spread out. So if you pump them into a tank, what happens to those particles? They get closer together. And think about those images that we had, the graphics that we had.
I can easily change the state of matter because it's changing my face.
Right. And when you push the particles closer together, that's exactly how a liquid looks, right? When you think about the images that we have of solids, liquids, and gases, they're slipping past each other, right? They're not fixed, but they're also not bumping around and spacing out anymore. So that's how you get from a gas to a liquid, is by putting it under pressure. Now, something else also happens when you do that. Have you ever watched a propane tank getting filled at like a hardware store or something? Do you notice anything going on with it around the outside of it? If any of the gas comes shooting out? Or have you ever shaken one of those and felt it? It's cold, yeah. Now think about what happens when you're trying to turn a solid to a liquid to a gas. What are you doing with heat? Are you adding it or taking it away? Right, you're gonna heat most things. You're gonna heat water, for example, to make it into water vapor. Right. So if you cool it down enough, it'll turn into a liquid. If you heat it up enough, it'll turn into a gas. So the sum of the internal energy and the product of the pressure volume in a thermodynamic system is your enthalpy. And it deals with energy, usually in the form of heat. It represents a change in heat. So what's a thermodynamic system? Fun word.
Something with heat.
Yeah, it's a body of matter and or radiation or whatever, a system confined in a space by walls with defined permeabilities. Okay, that's a good one. What's permeability? You know what that means? Permeability, it has to do with how much something leaks. Kinda. So you could say certain materials are impermeable to water. If I spray water at my glass table, it's not going to go through it because it's impermeable. But if I spray water at a piece of fabric, it is permeable. So it has to do with leaking. So which separate it from its surroundings. So you're talking about the walls of something and how it's separated. Now the walls can be anything. The walls can be the walls of this house. The walls can be a tiny bottle. Your system can be however you're going to define it, but it has to do, so permeability is important. So if you think about this, if you think about taking an ice cube and putting it on the stove and heating it, or any way you want to heat it, you take an ice cube, you put it in a pan and you heat it, it's going to turn to water, and then it's going to turn to water vapor, and it's going to spread out into the system, which is pretty permeable, right? Going to leak all over the house. But if you put it inside of a plastic water bottle and take it from ice to water vapor, what's going to happen to the bottle?
The bottle's gonna melt.
Eventually, well, if you've got the lid on tight enough, what's going to happen eventually?
It's gonna start breaking.
Yeah, it's gonna blow, right? Exactly, because it's not permeable. So that's your system in that case. All right, so temperature versus heat. This is a concept you guys need to be, sorry, buddy. You need to be sure that you get and understand. So temperature, and these are tricky. Temperature is how hot or cold something is, right? So when people say, you know, what's your temperature everywhere these days? You can't go in anywhere without something shooting a little temperature gun at your head.
Fire tablets enter the waiting room. You have to get the fire tablet.
Yeah, it just came in again. That's Senya. She was there and then she wasn't. There she is. There she is again. So yeah, so it's a measure of how hot or cold something is. But what is that? What is hot or cold? Really what you're measuring is the average kinetic energy of the particles in an object. So if you touch something that is cold to you, feels cold to you,
Usually transfer heat.
it will transfer heat. Yeah, so heat's about transfer, but temperature is about how hot or cold something is. So think about water vapor again, or steam in this case, and an ice cube. All right, which one of those two substances is going to have more particle movement, the ice cube or the steam? Yeah, the steam is, yeah. So if you get the steam going, you've got gas, water vapor. So you've got gas form of water, right? Those particles are moving everywhere. They're bouncing off each other. In ice, they're fixed, right? They're all rigid and fixed together. So when you're measuring temperature, you're measuring how fast the particles are moving. That's really all it is. And it is associated, it's a type of energy associated with motion. So it's a type of energy that's kinetic. Kinetic has to do with motion, right? Heat, though, is different. Heat is the transfer of that energy between two systems. So if you do like an old school thermometer, right? And think about this, those little red alcohol thermometers like we have in lab, or that you might put under your tongue. You ever had the old glass ones? Yeah, with the red alcohol inside. They don't do the ones with the silver mercury anymore because mercury is toxic, but those were kind of fun. But anyway, if you do that, they're because mercury is cool. But anyway, if you have one of those and somebody pops it under your tongue, all right, now what you've got going on is heat transferring out of your body into that glass system with that little bit of red dyed alcohol inside, right? And you're going to cause the heat transferring out of your body into that liquid is going to cause the liquid to expand because the particles in the liquid are now going to be moving more. So the temperature increased because the heat transferred. Does that make sense? Temperature will increase when heat transfers to, and temperature will decrease if heat transfers out. So if you put a cup with water in the freezer, the heat's going to come out of that and the particles are going to move slower, right? So then you're going to get something that is changing state. Is it all kind of coming together now? The concepts of particle moving and how that has to do with the amount of energy in a substance and how that has to do with its state of matter, hopefully a little bit. So heat, also referred to heat energy or thermal energy, and it's typically measured in either BTU, calorie, or joule. We did calories a couple weeks ago, remember? So remember when you're eating something and it says, like my bottle of kombucha says it's 50 calories. So that being a unit of heat, it's saying if I consume that, I'm going to have that many units of fuel for that many units of heat, if that makes sense. So in physics, the second law of thermodynamics says that heat flows naturally. It says a lot of things, but this is one of the things it says, that heat flows naturally from an object with a higher temperature to an object with lower temperature. And it doesn't flow in the opposite direction of its own accord. So if you're trying to cool something down, you have to do that with some degree of intervention. It's not going to happen on its own unless it's moving from the system. Yeah, of its own accord, right. So remember, when you step on your cold tile floor in the bathroom, that tile is the same temperature as the air around you. But why does a tile feel cold if you step on it with your bare feet in the bathroom?
Because the heat
Yeah,
from
you're sucking the heat out of your body, right?
I wear shoes more often.
Right. So if you touch your feet after standing on the cold tile, do your feet feel colder than your hand?
Yes.
And that's because the tile, the temperature in the tile was lower and the energy shifted from your feet to the lower energy.
Heated floors.
Say it again.
Heated floors.
Heated floors. Oh yeah, heated floors. Yeah. Heated floors would be good. So we're gonna wait.
Sorry to interrupt you, but
No,
can I
you're good.
change my haircut after we do this? I'm sorry to interrupt.
No, yeah, we're running, sure. So molar heat capacity. So this is Senya's trying to ask me something. Hang on, babe. I don't know if it's not. You in the chat? I don't know if I can hear you or not.
You might have
I'm trying to turn this one up, but it's not. You know what? Where's the volume again? It's weird. It keeps echoing strange. Sorry, dog. You're backwards on my lap.
the dog's like, hey, what happened?
All right. What'd you say, Senya?
I was gonna ask you, something weird happened, like you were frozen for like the first few minutes and then it exited me out.
You got bumped? Okay. Not a whole lot. I don't think you missed a whole lot. We were talking about we were talking about go backwards. No, it doesn't want to go. Well, we were talking about heat transfer and energy.
Okay.
And like right here, let's see, you saw, did you see that screen?
I saw the screens, but like when you were talking, you were just frozen.
Oh, okay. So we talked about how if your system is, say, a plastic bottle that you put a piece of ice in and heated it up, it's going to behave really differently than if your system is your whole kitchen and you've put a piece of ice in a pan on the stove. And that's about permeability, which is how much something leaks. That's pretty much where we were. So we're going to touch on this idea of molar heat capacity. We're not going to spend too much time on it because this is more for the other class, but just so that you know, because it may come up in lab, and it has in the past a little bit. So your molar heat capacity
We're not like,
is, oh, what'd you say, Sonia?
we're not like writing anything down or like checking anything.
No, you're good. Just following along. So your
Okay.
molar heat capacity is the energy as heat needed to raise 1 mole of an element or a compound by 1 degree Kelvin. And we also call that the specific heat of a mole. So 1 degree Kelvin, what's special about the Kelvin scale? Does anybody remember?
Not many people use it except for.
We use it in science, but we don't use it anywhere else. What's different about Kelvin? Do you guys remember? Anybody? So
Can't be.
Kelvin, go ahead.
It can't be negative.
Yeah, it can be negative. It can't be negative, right? Because what we do with Kelvin is we have zero. What happens at 0 Kelvin? Does anybody remember?
Is that actually?
Yeah, so 0 Kelvin is actually like a theoretical temperature that we've never really gotten to. But the idea is that at 0 Kelvin, it would be so cold that all the particles would stop moving.
So there's like negative 276.
Yeah,
Something around that.
it's something crazy. I can't remember the number off the top of my head, but yeah.
It's way too cold.
So at
Put more nitrogen in it.
it's a theoretical number, but what happens at 0 Kelvin is all particles just stop moving. So it's that cold, right? That cold.
Has it ever been that cold outside in school?
No, it's never been that cold anywhere before.
Negative 40 maybe?
There would be nothing alive if it was 0 Kelvin. Like
So if we went outside,
it wouldn't. It doesn't exist so much, but we can still scale it based on. It's a theoretical thing, but we can scale it based on what we know. So we use. I know Ozzy normally gets a nap this time of morning, though he's just hanging. But anyway, it's the amount of heat needed to raise an element or a compound by 1 degree Kelvin, which is itty. All right, and sometimes it's written this way, and sometimes, oh no, sometimes it depends on the number of atoms, just something to know, okay, that it may come up later somewhere along the way. This, by the way, is Kelvin, if you're wondering who that dude is. He looks very sleepy. Maybe he's cold.
That just reminds me of one of my friends' names, Kellen.
Kellen? This is Kelvin. Yeah, looks tired. Yeah, everybody looks tired today. So when we're dealing with specific heat, you might see this formula. So it's heat equals the number of moles times the molar heat capacity times the change in temperature. And don't expect you guys to memorize this one, but just know about it. Know it's a thing, because like I said, again, it may show up somewhere along the line and you'll go, oh my gosh, I've never heard of this. So it's good to know that it's a thing, right? It's going to be more of a thing for the other class. So now enthalpy, we were talking before. So it tells you how much heat and work was added or removed from a system, which were the exact words that Alec used, right? And that is the change in temperature, right? And it's the sum of a system's internal energy and the product of pressure and volume, which we said. So you may see it written this way. Does anybody know how you would read this? Delta H equals
Triangle
Q. Do you remember what the,
H equals
here, I'll give you a hand. Do you remember what the Q meant?
Doesn't it mean heat?
There's Q, right? Here's that delta.
Change in temperature equals heat.
Just about. Let's see.
I feel like the H is something.
Delta something
Dang it.
equals heat. So what did we just say? What did we just say up here? What's this? Yeah, your change in enthalpy, your change in energy of a system is the heat, and the heat's transferring in or out. So your change in your total energy of a system,
H does represent enthalpy.
so your change in enthalpy or your change in your total energy of a system is going to be how much heat, and heat is transferred in or out. Does that make sense? So if you have your change in a system, your energy is either going to go up or down, and it's typically going to be as heat. So it's either going to gain or lose heat, which we were saying right here, added or removed, right? Make sense? Not at all? Clear as mud? Y'all are funny. You're staring at me because everybody's like, yeah, it feels like the worst Monday ever, and it's not even a Monday.
Wait. For a second, I was like, wait, it's Monday.
I
Eleanor
woke up like 10
Oh my
minutes
gosh.
ago.
Hang on, Jocelyn, what'd you say?
I woke up 10 minutes ago.
Daggone. She made it to class. Impressive.
I would have just been like,
So your energy.
I woke up 7 hours ago.
Why?
why?
Why? So your enthalpy of a system is its total energy, which we were saying. Poor Lily is just hanging on, man. She's just hanging on today. So energy is only measured in joules, but remember we were talking about how enthalpy can be, energy is only measured in joules, but enthalpy can be joules or joules per mole. We're saying joules a lot today. Your ears must be perking up every time I say joules. Like what? Okay, and then enthalpy is also a form of energy. Energy exists in a state of matter, but enthalpy is always the energy change between two states. So think about that for a second. Let that one sink in. Energy exists in a state of matter, but enthalpy is always the change between two states. So if you can visualize this in your head, you got energy in the ice cube and energy in the water. And that bit in between where it's changing your enthalpy. You can see it there. You can see the total energy of your system when it's changing, right? If it's not changing, you can't see it. It's the change that you can measure. It's hard to measure it if it's not changing. Like if somebody said to you, how much did you grow last year? If you didn't have the first measurement and the second measurement, could you do the math to see how much growing happened?
No.
No, you have to have the first and the second.
I thought you said if you had.
Oh, yeah, exactly. So if somebody said to you, how much did you grow last year? And they're just looking at you right now, can they tell? No, but it's the change that can be measured as growth. You can tell your height. You can think of height as energy and growth as enthalpy, if that helps. And then energy can be only positive, but enthalpy can be both positive and negative. So when would your enthalpy be negative versus positive? What do you think?
When you get cold? It's
When
like-
something gets colder.
well, you technically can't be negative, but like you can get colder. That's not, it doesn't mean negative, it just means you're getting colder.
Right.
Measurement of how, like,
Mathematically, your answer would be negative. If you were doing the equations to try and determine, so let's think of it this way. If one year you were 4'12" and the following year you were 4'10", would you consider that growth in a positive direction or shrinking?
you said 4'12", you meant 5?
Yeah, I was trying to make it easier, but yeah, 5 foot, sure. Say you're 5 foot and the next year you're 4'10".
Then you're pretty old.
You're shrinking.
for your age.
Right, so
Yes, so
you're shrinking, right, Jocelyn, you're shrinking.
I'm
So
taller than my mom.
if the word shrinking didn't exist and you only had positive growth or negative growth, which would it be?
Negative growth.
It would be negative growth. So that's exactly how enthalpy is. So you get negative enthalpy when your energy decreases.
I'm taller than my mom.
It's like after like adult, once you get really old.
Yeah, what did you say, Jocelyn?
I'm taller than my mom.
You're taller than your mom?
I'm gonna be taller.
Like about an inch. She was in sneakers and I was in socks and I was still taller than her.
Wow.
She said that.
Well, your mom's kind of short. She's I don't think she's much taller than me. How tall is your mom?
I don't know.
How tall are you?
Last time I went to the doctor's, I was 5'3".
Oh, okay, yeah, I'm 5'2.5". So yeah, your mom's about my height, I guess. Wow.
You can get help after all.
So enthalpy is a word for energy. It includes molecular potential energy, as well as the change of heat between different compounds or systems. If you just think about the word molecular potential energy for a minute, think about those words. That's kind of a complex thought. But if you remember what potential kinetic energy is, it's the car sitting at the top of the hill waiting to roll down. Like it's got energy because of its position, and you'll see that energy when it moves. It's the same sort of thing with molecular potential energy, but it's got to do with bonding. And then, so here's your energy increasing and decreasing that we were just talking about. Here's your visual for it.
Were we supposed to like write in the circle? Or...
No,
Okay.
y'all were just supposed to read through it. These, like I was just saying, these next 2 weeks are going to be kind of light for your class because we're just making sure, huh? You did have some homework, yeah, but there weren't.
I had to do that like 10 minutes before.
Oh, I
because
forgot to put the
just found
folders out over there.
Just one question. If you actually didn't need the entire page, you could just
Mhm.
do like one sentence, like
Yeah.
words. But...
Who's chatting with me? It's flashing. That sound kind of weird, but I don't know what intermolecule. Okay, so there are two terms. There's inter, right, and intra. Those are two roots. All right, put them there so you can see them for a second. What's an interstate? If you get on the interstate highway, like 85, does 85 stay within Georgia or does it go outside of Georgia?
Probably goes out.
It is. It's an interstate. So inter means it goes between things. What do you think intra means?
inside.
Yes, good, Eleanor. So intra stays
I was just
within.
thinking of iron.
So if you were saying intramolecular, you would mean within one little molecule all by itself. But if you're saying intermolecular, you're dealing with one molecule and the molecule next to it. So intra means like within something, and inter means how things interact with each other. So an interstate goes between states. Can you think of a word with intra in it? That's intro. That's very close.
Wait, really?
I'm trying to think of a word. What's intra?
I almost thought that.
If I type intro, what will be the first word that Google autofills? What do you think? Or Safari or whatever this is. Google. What's going to fill? Intractable pain. That's intrapersonal. That's a good one.
That's nothing.
Intranet. Your intranet would be like within your system. Intracranial. Oh, there's a good one. Intracranial hypertension. What's hypertension?
You extend yourself too far? No.
No.
Something.
Does anybody know what hypertension is?
Is it being too hyper or too excited?
Hypertension is the word we use for high blood pressure. There's too much tension in your blood vessels, hypertension. What would be intracranial? Where's your cranium?
Cranium?
Your skull is your cranium. So if it's
I knew it.
intracranial, what is it?
Too much pressure
What you got,
building up in your brain.
Yes, too much
In
blood
your
pressure
skull.
building up inside your skull. That would be intracranial hypertension. There you go. All right. So
I knew
hopefully
it
that
was-
helps. Yeah.
had a nice word for it,
So
and I
here's
thought
your-
it was cranial.
Yep. Here's your heat absorbed into a system. You guys saw this in your notes, right? And your heat lost.
Mhm.
Growling.
I didn't think that.
Oh, Lily, he can't figure out what you are. Look. He's growling. It's just Lily, see? Lily put her hood down and he's like, what is that thing? It's Lily. No, Lily, because she's got her, you don't need to draw anything, Senya. You're good. So your enthalpy increases, you're putting energy into a system. If your enthalpy is decreasing, you're taking energy out. And usually that energy is going to be in the form of heat, right? Right. All right, so now I'm curious, does anybody have I don't think anybody put their homework up yet because I forgot to put the folder out.
No, I'm sorry.
No, I'm wondering if anybody would like to give me what's your what's your answers?
Exactly what I stated earlier.
Exactly what you stated
I
earlier.
said like the measure of heat because I didn't want to copy like exactly what you said, how heat was removed or added, even though that's the exact same thing. I was too lazy to come up with my own theory of that exact thing, so I just said the measure of heat, which is kind of wrong though.
Measure of heat, which is kind of wrong though. What do you guys think? Does anybody want to try and give me?
Completion, right?
No,
It's
because
completion.
This is
no,
completion.
I had issues with thinking of my own kind.
It's hard. Yeah, I was wondering if anybody had any
Don't say the measure of heat.
any
say,
different way.
Don't say the measure of heat. Say no. Sorry. Don't say the measurement of how much heat was added or removed. Just say a measurement. Just say
A
the
measurement. There you go.
Super
A
easy.
measurement of how much heat was added or removed. You could say that. That's a little different, I suppose. Yeah. So yeah, what I was looking for was to see if you guys could come up with some kind of wording for your own definition. It's definitely a challenge. I will put the folders up since I forgot to stick them up there. I don't know why I did that. This guy, yeah.
Is it cheating? Can I ask my dad for a little bit?
No. Homework is always completion and giving it an attempt. The only time I take points off homework is if you just don't answer something, or if your answer is so out of left field that it's not like an honest try. Like I look at that and go, that was not a try. Like you write oranges and apples for a question that I asked something completely different for.
You know that pin you gave us? I used it for the thing.
Oh, good.
Would this be correct? The amount of kinetic energy that has been like added or removed. I was too lazy to actually.
No, that guy. So that's a good way to think about it.
I didn't want to. I was too lazy to actually change the added or remove. I did it.
Do you have one, Sonia? Did you want? What'd you get?
No, I just want to know, like, what do I kind of draw, Enrico?
Okay, so the only thing that we were turning in for homework today was that last page, the homework page. That's all I need to see. I don't need to see anything else. So, yep. Just try and give me your wording for whatever you had. So I'd love to know in our last 5 to 10 minutes if you guys could share either something you got or gave over the holiday break. Hopefully nobody else got COVID.
I gave migraine.
You gave
I
migraines?
made everybody's
Okay,
gifts.
so let Jocelyn go first. All right, go for it.
So, for Christmas, I got the book of the original fairy tales. It's kid friendly, but I got the Land of Stories, which is filled with all the original fairy tales, not like Disney movie ones, but fairy tales, as well as the rest of the series, The Land of Stories, which me and my mom really loved that series because my friend Rowan convinced me to get the first book and start reading it, and we really liked it. Another thing I got, I actually I had made everybody a picture and an ornament.
Oh, wow. That's cool. And are they like the Brothers Grimm fairy tales, like that kind of thing?
Cousins, grandparents, uncles, and aunts. And then I also made some for friends and teachers.
Oh, no, I was asking like were the fairy tales like the Brothers Grimm fairy tales, like Little Red Riding Hood and
Yeah, like those, just kid friendly, not as
not as brutal as they actually were
What's
originally.
funny was when I was scrolling through the table of contents, just like Steve was, like what fairy tales were inside. I found Mother Goose's fairy tale survival guide.
Oh, cool.
I read it, and rule number 5 was don't trust old people.
Oh, that's funny. Don't trust old people. How about you, Sonia?
But I mean, if you think about it, a lot of the villains were old people. Because
Yeah,
Nicole
true.
up old people as like kind and caring and not as like dangerous as you think.
Right.
Because like
How
people.
about you,
either-
Sonia? How'd you do for Christmas or anything over the holiday?
I got a small Bluetooth speaker. It's waterproof, sandproof, snowproof, and everything.
That's cool. Is it for your room?
No, it's for like dancing and hook it up to a phone and plays music.
Do you know that Sonia does like Irish step dancing type stuff? It looks exhausting if you've never seen it. It's crazy. Good for you. How about you, Dantoni girls? How did you do? I know what Jules got. Jules got COVID. What else did you get? What else did you guys get over break?
I got more masks and I got a book.
Cool.
Called Wings of Fire. It's a really cool comic book. Are you gonna do it?
No. Oh, wait, she can't see
Oh.
us.
Oh, there you are. Oh, cool. That looks great.
Yeah,
Hey,
that
Jules, we feeling
is-
better.
It's an issue because I
Wait a minute,
I
let-
want
hang on, wait a minute, wait, go to the-
one.
We're saying we miss you.
That is awesome. How about you, Ella? How'd you do?
Good. I got this. Don't stare.
Oh, okay. Got
Jeez, you're staring at me. I got this really cool like resin stuff, and you like pour it into different molds, and it dries hard, and then you can make different creations and stuff.
That's cool. That sounds like a lot of fun. Crafty stuff is always fun. Very,
I
very
also
cool.
gave you that kit.
I don't stop.
Cool. How about you, Alec? How'd you do?
I got like $360, and then I had like clothes, like a book, and then some stocking stuff. My mom's supposed stocking is like, just normal. It's not meaningful. And then for my dad, he's actually, it's still in the mail kind of, but a motherboard and RAM, computer parts. Like, motherboards are worth like 150, and then RAM is probably like 100.
Very cool. Excellent, excellent.
$100.
Very cool. All right, how about you? What'd you get, Sky? Or would you give? A what? Nintendo Switch?
And a headset.
Very cool. Eleanor?
I got MHA pens that I can put on clothing, and I also got an MHA book.
What's MHA?
MHA is My Hero Academia. It's an
Okay.
anime. Jules watching it, Ivy's watching it.
Okay, okay,
I'm watching
okay.
it.
Uh-huh.
I got book 1, 2, 3, 4, and 5.
Nice.
Well, I already had book 1, but then I got 4. Like I got 2, 3, 4, and 5 for Christmas.
Looks like you got your nails done too.
I painted these myself.
Nice. They're long. Wow.
They're
Impressive.
long because my nails grow really fast.
Wow. Did you take vitamins? That'll do it.
No.
No?
No.
How about you, Lily?
I got a longboard.
You got a longboard? Nice. Okay.
I got a Polaroid camera.
Cool.
I got a ukulele.
Oh, I have a ukulele.
Oh, take a picture of this screen that this prints out. Oh yeah.
Oh,
It's from like this school project. They're like,
What else?
and then I just got stocking stuff.
Mm-hmm.
I got some clothes.
Cool. That's cool. I think, well, I got,
And then I got a gift card for my
so I'll do one thing I gave and one thing I got. So the one thing that I'll do it this way, that were the biggest surprises. So the one thing I gave that was the biggest surprise was for Jason. He has been wanting to do like a winter trip to a mountain cabin for a long time. He said something about being in a cabin in the winter and like having like a hot tub outside when it's cold like that. He just wanted to do that. So I got a cabin in, it's outside Chattanooga, Tennessee, near Lookout Mountain. But the big part of the gift, that was part of it. We're going in February, but I got him a hang gliding trip that weekend. So it's a tandem hang gliding, but they just literally run off the side of the mountain with you attached, and then they take off and you're hang gliding, which I found it on Groupon, and I was so excited because that's the kind of thing that he would love. So he's excited. We're going in February, and then yeah, and then the most exciting or most surprising thing I got was, you ever heard of Cameo? It's this, it's an app where you can get celebrities to send personal messages to people. You pay them a small amount or whatever, and then they'll send a personal message to whoever you want. So I don't know what inspired Jason, but he got on Cameo and started looking for something for me. And he found a celebrity that I really like, and he sent me a personal message.
celebrity.
And yeah, it's Penn Jillette. He's part of the Penn and Teller Magic thing, but he's somebody that he's also has some like political, ideological stuff that he speaks about that I like. So it was really kind of cool because not only did he give me a message, but he gave all of you guys a message. Like he said, tell your, Danny's class, it's going to be a better year and all this kind of stuff. It was just really cool. I was so shocked I nearly died. So it was just a big surprise. It was a big, big surprise. Well, we're going to go ahead and split. So for you two girls that are my cyber people, you've got everything in your kit except your egg yolk, I think, and water. So you'll need to hard boil an egg if you've never done that before. Yeah, Senya's like, I don't know about that. You have to hard boil an egg. So somebody can show you how to do that, or you can look it up.
I
It's
got
pretty
it.
easy.
Easy.
Yeah.
Do that.
And then you D'Antoni girls can just get that information from somebody, or most of this you can probably try at home too. It's not too hard. No special equipment, kind of up to y'all. But
Okay.
I'm gonna let you guys go. So we will see you all later.
Bye.
Bye,
bye.
everybody.
Yeah.
Watch the experiment.